Alright, so today I'm going to be showing you how to do a dihybrid cross for genetics. This is a pretty commonly missed question on the quiz. So they give you the parents, right? You have parent 1, parent 2, two traits for each parent. So the first thing you need to do is figure out all the possibilities of gametes that this parent could produce. So parent 1 can give either a big B or a little b, and they can only give a big L, right? So we're going to get 4 combinations here. They could give this big B, this big L. They could give this big B, this big L. Sorry, it's hard for me to film and write at the same time. They could give this little b and this big L. Or they could give this little b and this big L. So those are the 4 possibilities for gametes for parent 1. For parent 2, they can give a big B, big L, or a little l. So again, first possibility is going to be a big B and a big L. That would be the first big B. They could also give the first big B and the little l. They could also give the second big B and the big L, or the second big B and the little l. So these are the possibilities of gametes for the second parent. So then we set up one of these Punnett square type situations so that we can calculate the options. So first one would be a big B, big L, going across, big B, big L, big B, little b, big L, big B, little b, big L, big L, big B, big L, little l, big B, big L, little l, big B, little b, big L, little l, big B, little b, big L, little l, big B, big L, big L, big B, big L, big L, big B, little b, big L, big L, big B, little b, big L, big L, big B, big L, little l, big B, big L, little l, big B, little b, big L, little l, and big B, little b, big L, little l. Right, so I wrote them in order of uppercase to lowercase. You could have written it in any order really. The order is not important. So now we have our final chart. So we have to figure out all the possibilities we could have. We could have big B, big L, big B, little b, big L, big B, big B, little l, big L, little l, right? Because there's no way we could get 2 little l's if we look back up here. Then we can have big B, big L. Nope, already did that one. Big B, little b, big L, little l. I think I got all of them, right? And we can't have 2 little b's because each parent would have to be able to give 1. So these are possibilities that we could have in the end. So you can actually go into the chart and see percentages of those, right? Which I'm not gonna, actually we could do that. So big B, each of these squares, right? We have 1, 2, 3, 4 by 4. This is gonna be out of 16. So how many of our boxes are big B, big L, big L? 1, 2, 3, 4, 4. So 4 out of 16, right, are big B, big L, big L. So we can reduce that, right, to 2/8 and then to 1 over 4, which would be 25%. Our big B, big B, big L, big L. Now we're looking for big B, little b, big L, big L. So we have 1, 2, 3, 4. Just checking to make sure that's right. Yep, we have 4 again, which means that there are 25% of big B, little b, big L, right? So that's accounting for 50%. 1, 2, 3, 4, 5, 6, 7, 8, right? 8 boxes have been crossed out. And then next we have big B, big L, little l. So we have 1, 2, 3, 4. We have 25%. And then without even having to count, we know that our last one is also 25%. Right, so this is pretty evenly divided. We also know that every single one of these offspring are going to show the dominant traits, right? So in this case, they will have brown spots and black spots. All will have black spots and long tails. Right, so this is a little messy, but each of the genotypes is 25% written here. But the phenotype, or how they look, they're all going to have black spots and long tails, because every single possibility here, they have a big B and at least one big L. So hopefully that helps you understand a little bit how to do these dihybrid crosses. The biggest, most important part is identifying the genotypes. So I'm going to show you one more that's a little bit more complicated. If we have T's for tall, a big T equals tall and a little t equals short, and we have a G for green, right? And a little g will equal yellow. I guess I'll write the little t is going to equal short. So if we have one parent who's big T, big G, little g, being multiplied by a parent who is big T, little g, little g, right? The first step here is going to be to identify the possible gametes. So for parent 1, they could give the big T with the big G. They could give the big T with the little g. They could give the little t with the big G, and they could give the little t with the little g. Parent 2 could give big T with little g, big T with the other little g, little t with the little g, and little t with the other little g. Right? Those are the possibilities. And you really want to think about this being in one cell, right? And the independent assortment possibility. So again, you would set this up. You would go through your cross, big T, big G, little g, right? You would fill the entire thing out, and then you would calculate your percentages and your genotypes and phenotypes. So I'm going to encourage you to go ahead and finish this example and see what you get.